Hello students. Uh, Now we are coming to the last lecture of the first unit, and this lecture is basically again on TCP. And now we are going to discuss two other important concepts of TCP. One is the TCP flow control, and the next is the very important concept, that is TCP congestion control. So the topics that we are going to cover in this lecture will be initially starting with the window size of TCP, and we are going to look at how the receiver has a control over the sender application, wherein the receiver controls the amount of segments that can be sent over the TCP. We all of us know that in case of TCP, the protocol data unit exchange is termed as a segment. Then we are going to look at another important concept, that is three-way handshaking. And this three-way handshaking is applicable whenever TCP tries to establish a connection based on a control flag which is known as synchronize or sync, and whenever TCP tries to terminate a connection based on a control flag which is known as final or fin. So we are going to look at the three-way handshake mechanism of TCP, and then something new that we are going to cover with this three-way handshaking is the finite state machine verification of TCP algorithm. Okay. So now what is the verification of a algorithm in a network? So we can decide a finite state machine, and where the set of states and the transitions from those set of states will define the behavior of TCP, and we are going to validate whether this behavior is correct or not. Okay. Then we are going to look at the another important aspect of TCP, that is the TCP congestion control algorithm. And on this TCP congestion control algorithm, there are different variants that the TCP supports. Okay, like there are two important variants that the TCP supports. One is the TCP new Reno algorithm, and one is the TCP Vegas algorithm. So we are going to look at the standard TCP congestion control algorithm, and then we are going to look at the variants of TCP. And now we are going to see that whenever TCP forms a implicit congestion control, then how does TCP guarantee a desirable throughput, and how does TCP achieves a fair amount of you can say fairness in case of satisfying all the flows. So this is the second part of the lecture, wherein we are going to discuss the aforementioned topics, and I welcome you all to be the part of this lecture. Thank you.